The statement emphasizes the critical need to understand the historical context and logic underpinning code provisions. While new interpretations and viewpoints are valuable, code changes must be based on a firm understanding of established knowledge and research. A concern is raised that some newer panel members may not have the necessary historical knowledge to fully grasp the reasons behind existing code provisions. This could result in changes based on subjective readings rather than a complete understanding of the code's intent and purpose. It is important to ensure that new panel members have access to and are familiar with the historical reports and documents related to the code to address this issue. This will give them a better understanding of the reasons behind the provisions and help them make informed decisions about changes. It is also important to have a process for reviewing and evaluating proposed code changes. This process should include input from experts from a variety of perspectives and backgrounds, including those with historical knowledge of the code. By considering multiple points of view and ensuring a thorough review, the code-making process can maintain its integrity and adapt to new challenges while preserving its basic principles. The National Electrical Code, or NEC, is a comprehensive set of standards designed to safeguard persons and property from hazards arising from the use of electricity. It's updated every 3 years to reflect changes in technology, address new safety concerns, and clarify existing requirements. The code development process is overseen by the National Fire Protection Association, or NFPA. Understanding the structure of the NEC is crucial for effective application. The NEC is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. Chapter 1 covers general requirements, such as definitions and scope. Chapters 2 through 7 cover specific rules for wiring and protection, wiring methods and materials, equipment for general use, special occupancies, special equipment, and special conditions. Chapter 8 deals with communication systems, and Chapter 9 contains tables and examples. Articles within each chapter provide more detailed requirements for specific topics. For example, Article 210 covers branch circuits, while Article 250 covers grounding and bonding. Sections within each article offer specific rules and guidelines. For example, Section 210.52 covers receptacle outlet requirements in dwelling units. The code-making process is a multi-stage process that involves proposals, comments, revisions, and voting. Any interested party can submit a proposal to amend or add to the NEC. These proposals are reviewed by code-making panels, or CMPs, which are comprised of experts in various fields of electrical safety. CMP consider the proposals along with public comments and develop revisions to the NEC. The revised code is then subject to further public comment and revision before being finalized and published. Understanding the roles and responsibilities of different stakeholders is essential for effective participation in the code-making process. Electrical inspectors enforce the NEC and ensure that electrical installations meet safety standards. The electrical contractors install and maintain electrical systems in accordance with the NEC. Electrical engineers design electrical systems and ensure that they comply with the NEC. Manufacturers of electrical equipment must comply with the NEC standards for their product. Users of electrical equipment should be aware of basic electrical safety practices and follow the NEC guidelines. Staying up to date on code changes is crucial for electrical professionals. The NEC is updated every 3 years, so it's important to stay informed about the latest revisions. There are several ways to stay up to date on code changes. Attend NEC training courses and seminars. Read the latest edition of the NEC and related publications. Subscribe to electrical industry newsletters and magazines. Participate in online forums and discussions. The NEC addresses a wide range of electrical safety topics, including grounding and bonding, overcurrent protection, wiring methods, equipment installation, and special occupancies. Grounding and bonding are essential for preventing electrical shock and fire hazards. The NEC requires that all electrical systems be properly grounded and bonded to provide a low impedance path for fault currents. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the types and sizes of overcurrent protection devices that are required for different applications. Wiring methods refer to the types of conductors and raceways that are used to install electrical circuits. The NEC specifies the allowable wiring methods for different applications and environments. Equipment installation refers to the proper installation and connection of electrical equipment such as lighting fixtures, receptacles, and appliances. The NEC provides detailed requirements for equipment installation to ensure safety and proper operation. Special occupancies such as hospitals, hazardous locations, and swimming pools have unique electrical safety requirements. The NEC provides specific rules for these occupancies to address the unique hazards that they present. Common code violations can lead to electrical hazards and should be avoided. Some common code violations include improper grounding and bonding, overloaded circuits, undersized conductors, improper wiring methods, and damaged equipment. Understanding the NEC is essential for ensuring electrical safety. By following the code requirements and staying up to date on code changes, electrical professionals can help to prevent electrical hazards and protect persons and property from harm. Specific examples of code requirements and their applications can further illustrate the importance of the NEC. For example, Section 210.8 requires ground fault circuit interrupter, or GFCI, protection for receptacles in dwelling unit bathrooms. This requirement is intended to protect people from electrical shock hazards in wet locations. Section 250.50 requires that all grounding electrodes be bonded together to form a grounding electrode system. This requirement is intended to provide a low impedance path for fault currents and to minimize the risk of electrical shock. Section 310.15 specifies the allowable ampacities of conductors based on their size, insulation type, and installation conditions. This requirement is intended to prevent conductors from overheating and causing fires. These examples illustrate the importance of understanding and applying the NEC correctly. By following the code requirements, electrical professionals can help to ensure electrical safety and protect persons and property from harm. Understanding the history and evolution of the NEC can provide valuable insights into the reasons behind the code requirements. The NEC has been developed and revised over many years based on experience, research, and technological advancements. By understanding the history of the code, electrical professionals can gain a deeper appreciation for the importance of the code requirements and the rationale behind them. Resources for learning and applying the NEC include the NEC itself, NEC handbooks, training courses, online forums, and industry publications. The NEC handbook provides explanations and examples to help users understand the code requirements. Training courses offer in-depth instruction on the NEC and its applications. Online forums provide a platform for electrical professionals to ask questions and share information. Industry publications provide updates on code changes and industry trends. By utilizing these resources, electrical professionals can enhance their knowledge and skills in applying the NEC. The NEC is a vital tool for ensuring electrical safety. By understanding the code requirements and applying them correctly, electrical professionals can help to prevent electrical hazards and protect persons and property from harm. Continuous learning and staying up to date on code changes are essential for maintaining competence and ensuring compliance with the NEC. The code-making panels are responsible for reviewing and revising the NEC every 3 years. These panels are composed of experts in various fields of electrical safety, including electrical engineers, contractors, inspectors, and manufacturers. The code-making process is open and transparent, allowing any interested party to submit proposals for changes to the NEC. The code-making panels consider all proposals and public comments before making revisions to the NEC. The revised NEC is then published and becomes the standard for electrical installations in the United States. The NEC is constantly evolving to reflect changes in technology and address new safety concerns. Staying informed about the latest code changes is essential for electrical professionals to ensure that their work complies with the NEC. The NEC is not law unless it is adopted by a state or local jurisdiction. However, the NEC is widely adopted and enforced throughout the United States. Many insurance companies also require compliance with the NEC as a condition of coverage. Therefore, it is essential for electrical professionals to be familiar with the NEC and to comply with its requirements. The NEC is a complex and comprehensive document, but it is essential for ensuring electrical safety. By understanding the code requirements and applying them correctly, electrical professionals can help to prevent electrical hazards and protect persons and property from harm. Continuous learning and staying up to date on code changes are essential for maintaining competence and ensuring compliance with the NEC. The NEC is a living document that is constantly evolving to reflect changes in technology and address new safety concerns. Electrical professionals must stay informed about the latest code changes to ensure that their work complies with the NEC and that they are providing the highest level of electrical safety. The NEC provides specific requirements for various types of electrical equipment and installations. For example, the NEC provides requirements for the installation of wiring, overcurrent protection devices, grounding and bonding systems, and electrical equipment in hazardous locations. The NEC also provides requirements for specific types of occupancies such as hospitals, schools, and commercial buildings. Electrical professionals must be familiar with the specific requirements of the NEC that apply to their work to ensure that they are complying with the code and providing a safe electrical installation. The NEC provides detailed requirements for the selection and installation of conductors. The NEC specifies the allowable ampacity of conductors based on their size, insulation type, and installation conditions. The NEC also specifies the requirements for conductor identification, splicing, and termination. Electrical professionals must follow these requirements to ensure that conductors are properly sized and installed to prevent overheating and electrical hazards. The NEC provides detailed requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the types and sizes of overcurrent protection devices that are required for different applications. Electrical professionals must follow these requirements to ensure that electrical circuits are properly protected from overcurrent conditions. The NEC provides detailed requirements for grounding and bonding. Grounding and bonding are essential for preventing electrical shock hazards and ensuring the safe operation of electrical equipment. The NEC specifies the requirements for grounding electrode systems, equipment grounding conductors, and bonding jumpers. Electrical professionals must follow these requirements to ensure that electrical systems are properly grounded and bonded. The NEC provides detailed requirements for electrical equipment in hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. The NEC specifies the types of electrical equipment that are permitted in hazardous locations and the requirements for their installation. Electrical professionals must follow these requirements to ensure that electrical equipment in hazardous locations is safe and does not pose a fire or explosion hazard. The NEC provides detailed requirements for specific types of occupancies. For example, the NEC provides specific requirements for electrical installations in hospitals, schools, and commercial buildings. These requirements are designed to address the unique electrical safety needs of these occupancies. Electrical professionals must be familiar with the specific requirements of the NEC that apply to the type of occupancy they are working in to ensure that they are providing a safe electrical installation. The NEC is a complex and comprehensive document, but it is essential for ensuring electrical safety. By understanding the code requirements and applying them correctly, electrical professionals can help to prevent electrical hazards and protect persons and property from harm. Continuous learning and staying up to date on code changes are essential for maintaining competence and ensuring compliance with the NEC. The code-making process is a collaborative effort that involves many different stakeholders. The code-making panels are composed of experts in various fields of electrical safety, and they rely on input from the public to make informed decisions about code changes. Any interested party can submit proposals for changes to the NEC, and these proposals are carefully considered by the code-making panels. The public also has the opportunity to comment on proposed code changes before they are finalized. This open and transparent process helps to ensure that the NEC is a fair and effective document that protects the safety of the public. The NEC is a valuable resource for electrical professionals and anyone else who is involved in electrical work. By understanding the code requirements and applying them correctly, we can all help to prevent electrical hazards and protect persons and property from harm.